Hey there everyone, welcome to the Covering and Surrounding Unit Review. At this point you should have already completed the review, so if you have not done so, make sure that it is completed before you go ahead and look at this video. Make corrections after you're done with it and use this video to study. So getting started, we have number one and two, we are finding the faces, edges, and vertices of the two shapes that we see here. So as a reminder, faces are the flat surfaces of a 3D object. So as we can see in number one, we see a triangle, or we see two triangles, and we see three rectangles. So we would say that the total number of faces are 5 faces, because if we count, we see there are the two triangles at the end and then the 3 rectangles in the middle that connect those together. Edges are the lines that connect the vertices, so it's where 2 faces meet as well. And if we count, we see that there are 3 edges in the front, 3 edges in the back, and the 3 edges that connect those 2 faces together as well. So the total edges are 9. Vertices are where our edges and faces meet. We know this from previous investigations where we've talked about the vertex of a shape. So vertices is the plural form for vertex, and we see that there are 1, 2, 3, 4, 5, 6 vertices in the shape. Moving on to number 2, we see that there are 6 faces. There are the 2 on each ends. We have the left and right face, and then we see 4 other rectangles that connect those faces together. So we have a total of 6. Very similar to a cube, and if you think of a cube, or if you think of dice, they have 6 sides, so they have 6 numbers. Moving on to the edges, we see that there are 4 edges on the left side of this rectangular prism. We see that there are another 4 on the right side. That is a total of 8 so far, and then we see that there are 4 edges bringing those 2 together. So we have a total of 12 edges here. And the vertices, we look for the edges that meet, and we see that there are 4 edges that meet together at the different vertices on the left side, and then we also see that there are another 4 vertices on the right side, giving us a total of 8 vertices. For numbers 3 through 5, we are finding the area and the perimeter of each figure. As you see, there are 2 parallelograms. Number 4 and 5 are parallelograms. That's what we've done more recently. And then we also see a triangle, which we saw back in investigation 2 when we were finding area and perimeter of a triangle. So let's go ahead and start off with number 3. We know that perimeter is the total distance around an object, so we are going to add up all the side lengths, which we know for a triangle are a total of 3. So I'm going to go ahead and say perimeter equals 5 plus 8 plus 13.2. And it's a little bit tricky when we see that they're including the dotted line here, and we see that it says 6 centimeters, but we need to remember that that is not a part of the triangle, so we do not include that in our perimeter. What we do use that for, though, is for finding the area, which we'll see in a minute. But moving on to continuing with the perimeter, we know that 5 plus 8 is 13, and then 13 plus 13.2 gives us a total of 26.2. So we would say this is 26.2 centimeters. And I would go ahead and box in my answer. Okay, moving on to the area of the shape. This is where I have to think back to the formulas that we've used, and I know that area equals half base times height for the area of triangles. So I can go ahead and now plug in half. I know my base is 5 centimeters because that is the bottom of the triangle, and this is where those 6 centimeters come into play. This is where we can use this information to see that the height from the top of the triangle, or the highest vertex, down to the base of the triangle has a distance of 6 centimeters. So I'm going to say that the height is 6 centimeters, and I'll plug that in here. So I can now say that area equals half After I multiply 5 times 6, I get an answer of 30. And after multiplying by half or dividing that 30 by 2, I get a final answer of 15 centimeters squared because we are working with area. All right. So that is the work that you need to show for the perimeter and area of that triangle in number 3. Moving on to number 4, we have a very similar process. For the perimeter, we are going to add up all the side lengths. I know perimeter equals the 4 side lengths that we see. It does not tell us all 4 side lengths, but we know using prior knowledge that in a parallelogram, the opposite sides are going to be congruent side lengths. So I know that the top side length here is 8 inches and the right side length is 6 inches. So when I go ahead and plug these numbers in, I get 6 plus 8 plus 6 plus 8. I know 6 plus 8 is 14, and 14 plus 6 is 20, and 20 plus 8 is 28. So I can go ahead and say perimeter equals 28 inches. Again, this is not squared because we are only talking about distance and not area. Moving on to the area of the shape, the formula that we saw in investigation 3 is similar to that of a triangle. However, because this is more similar to a square, and we know squares are length times width, we are going to use the formula area equals base times height. In this problem, or in this figure, I see that the base is 8 inches and the height is 3. Now, this again is where it's very important to know that we are not using the side length that's on the left or the right of the parallelogram, but instead we're going to use the information that's given on the height, which is on the far right in the dotted line. And if we remember back to when we learned about this, we said that if you drop a rock from the top of a shape, it falls straight down and it forms that right angle at the bottom. So we know that that is definitely the height of it and that we should be multiplying 8 times 3. After multiplying, I get an answer of 24 squared inches. Again, because this is area that we're working with. So that completes our work for number 2. We can move on to number 4, and now we can move on to number 5. Similar to what we did with the last 2 problems, we are going to find the perimeter. Here, again, we know that the opposite sides are congruent, so I can go ahead and say that the top length is 6 inches, and the right side of this parallelogram is 7.5. I can say perimeter equals 6 plus 6 plus 7.5 plus 7.5. Again, there are other ways of doing this. You can do 6 plus 7.5 times 2. And as long as you are adding up a total of those 4 side lengths, your answer should be correct. I know 6 plus 6 is 12, 7.5 plus 7.5 is 15, and 15 plus 12 is 27. And this is in inches. So that is my final answer for that there. We can move ahead onto the area. The formula for area, again, is going to be base times height because it's a parallelogram. I can say area equals 6 inches times a height of 7. Again, this shape might be a little more confusing because it's not as slanted. We might think that that 7.5 is our height, but we need to remember that that does not form a right angle at the bottom as this dotted line does. So 7 inches is our height. And we can now go ahead and say that our area is 42 inches squared. Number 6 and number 7 are nuts of a 3D objects. So these are 3D objects that are laying flat or that have been broken apart. So it says for these that we are going to find the surface area of each of these figures. So going in with number 6, we know that there are a total of 2 different shapes, which means we are going to have to find the area using 2 different formulas. Again, surface area is the total area of all objects combined, so we are going to find the area of each individual shape that we see, and then our final step would be to add up those areas together. So going ahead and looking at number 6, I do see that we have a triangle, or 4 of them actually, 4 triangles and a square. And I know that my formula for my triangle is going to be half base times height. And I know my formula for the area of the square is going to be length times width. So using this information, I'm going to go ahead and get started with finding the area of that triangle that we see off to the right. So again, we've talked about the height of triangles, how we want to picture the base laying flat on the ground. So even though this triangle has the information of the 5 centimeters going from left to right, we want to visualize that triangle being rotated counterclockwise about 90 degrees, so that the base of it is laying on a floor, and we are given a height of 5. So if it helps, you can go ahead and draw those same numbers on a shape that is a little more easier to see. So we know that that has a height of 5 because all of these 4 triangles are congruent, and we know that these both have bases of 8 centimeters. And we know this because the distance from this vertex to that vertex is the same as it is from here to there. So we use that information from the opposite side to know that the base of the triangle is 8 centimeters. And we now have all the information we need to find the area of that triangle. So we can go ahead and say area equals half base times height. We can go ahead and plug in our numbers and say that area equals half 8 times 5. We can find the product of 8 and 5 and plug in 40 into our problem here. And then we can go ahead and divide 40 in half, or multiply it by the half, and say that area equals 20 centimeters squared. Now this is for one triangle, so I know that I have a total of 4 triangles. So I'm going to go ahead and either multiply by 4, or you can write this as 24 times, and then add the area of the last shape, which is that square at the very end. So let's go ahead and look for the area of the square. We know that area of any rectangle is length times width. Plugging that in, we have 8 times 8, which gives us an area of 64 centimeters squared. And this again is for the square that we just did. So if I go ahead and move this over, I know that this shape is composed of the 4 triangles that we just drew right here and found to be 20, and that one square with an area of 64. So if I go ahead and add these up, the total area of those 4 triangles is 80, and 80 plus 64 gives us a total of 144 squared inches. And that is our final answer for the shape. Moving on to number 7, very similar idea here. These are all rectangles, however, they are different in their sizes. If this was a cube, we can find the area of one face and multiply by 6. However, the left side and the right side are different than the top and the bottom, which are also different than the front and the back. So looking at this net here, I see that there are a total of 3 different shapes that we're going to have to solve for. The first one will be this smaller rectangle, which is a 2x4. After that, we can go ahead and solve for this slightly bigger and longer rectangle down at the bottom. And then we will also solve for the larger rectangle here in the middle that we see. Now, the important part to remember about this here is that we have 6 faces to solve for. However, if we solve for these 3, we know that there are a total of 3 other matching ones. So if we can go ahead and color code these, we can see that these are exactly the same as the ones that we just highlighted. Copy, whoops. You can paste this here and paste that again. So for the purpose of this and to stay organized, I'm going to go ahead and label this as our front facing rectangle, which means the opposite of it would be our back. I know that this is our right, which means this would be our left. And we're going to say that this is our bottom. If we imagine us folding this up, that rectangle at the bottom would stay at the bottom, which means the one that is opposite of that would be the top. This means that we have to find the surface area for the top, for the front, for the right, as well as for the bottom, left, and back. All of these are rectangles, so all of these are going to be length times width. So finding the area of starting with the top, I know that this has a height of 4 because I see that the height of this bottom is also 4, and all of these would obviously have a width of 12, seeing that the front side has a width of 12. So all of these, you don't have to label these, but if it helps, you can label all of those side lengths 12. You can label the left side as 4x2, and then we know that because this is a 4x2 and knowing that these 2 vertices will meet at some point, this is also, the front also has the sides of 2 inches. So now that we have most of our rectangles labeled, we can go ahead and say that we are going to multiply 12 times 4 for our top, giving us an answer of 48 squared inches. Our front is a 12x2, giving us an area of 24 squared inches, and our right is a 2x4, which gives us an area of 8 squared inches. Now, as I see there on the image above, the top is the same size as the bottom, so I can just go ahead and say that this is also 48. The left is 24. Sorry, no, the left is 8 because it is opposite of the right, and the back is 24. After finding all of these, we can go ahead and add them up. Or you can do 48 times 2 plus 24 times 2 plus 18 times 2. So we're actually going to go ahead and do that instead. So 48 times 2, 24 times 2, and 8 times 2. And this is representing our bottom and top. This is representing our front and back. And this is representing our left and right. So we can go ahead and highlight these. So again, this is our top and bottom. Oh, those are the wrong colors. Let's go with green. We have our top and bottom. We have our front and back. Last but not least, we have our right and left. And again, this is times 2 because there are 2 of each. So 48 times 2 does give us 96, 24 times 2 gives us 48, and 8 times 2 gives us 16. When we go ahead and add these all together, we get a final answer of 160. And this is 160 squared inches. Okay, and that is all the work for number 7. So we can go ahead and move on to number 8. Number 8 asks which of the 2 nuts that are pictured above in problem 6 and 7 would fold to make a pyramid, and we have to explain how we know. So just taking a look at these, if we picture folding these shapes, the triangles and the rectangles and all, we want these vertices to match up together. And as we know from our prior knowledge, a pyramid does have the shape of a triangle. So the most logical thing to say here is that it is most likely that number 6 will fold up into a pyramid because it has the 4 triangles that will meet to give that pyramid shape. It is kind of obvious that if you have 6 rectangles, those are going to fold up and give you a more boxy 3D object versus that pyramid that we're looking for. So our explanation can be based, or we can say looking at the nuts pictured above, the nut in number 6 is the shape that will fold to make a pyramid. And if you want to sketch a little pyramid off to the side, just to kind of get an idea of how those pyramids look, we can say that I know this because a pyramid is composed, that means it's made up of, composed of triangles, and can either have a triangular or rectangular base. Now, anything along those lines will be good as long as you are explaining, one, stating which one folds into the pyramid, and mentioning about how pyramids have or are made up of triangles. Moving on to numbers 9 through 12, we have a real scenario problem here where we're given 2 different sizes of popcorn. One size is the micro box, the other is the jumbo box. We're going to use the information that they give us to find the amount of cardboard that is needed to make the jumbo box. So that is our first problem in number 9. So we're going to go ahead and take a look at that jumbo box and try to figure out, again, the amount of cardboard that is needed. Now, just thinking about that there, we have to decide between whether we're going to use volume or surface area, right? But if we think about what the question is saying, asking how much cardboard, we know that we're not really talking about the inside of the box. Rather more, we are talking about what is making the box, what shapes are making it, how much of that, of those rectangles are being used to shape this, this jumbo box, right? So this tells us that we're working with surface area and that we're going to find the area of all of these faces that we see. So let's go ahead and get started. It does say here that there is no top on the box, which tells us that there is one less face that we're going to have to solve for in comparison to a regular rectangular prism, right? So breaking this down, we have, normally we have 6 faces. We usually have the top, the bottom, the front, the back, the left, and the right. Again, because this is a box of popcorn and because our problem tells us that there's no top, we will not have to solve for the top. We will only have to solve for the bottom, the front and back, the left and right. And if we remember, the front and back are opposite sides, so they're going to be congruent. So the front and back are congruent, which means the left and right will also be congruent. So why don't we go ahead and get started with the area of the bottom. We know that the bottom has a length and width of 6 and 10 just by looking at the shape here. So we're going to say area equals, so this is going to be for the bottom. Area equals length times width. We can go ahead and plug in 6 times 10. And we know that area equals 60 squared inches. Okay. Moving on to the front and back. We have area equals length times width. I see that the front has dimensions of 10 by 14, so I'm going to say this is 10 times 14, which gives us an answer of 140 squared inches. However, there are 2 here, so I need to find, or instead of finding, I'm just going to multiply this by 2, giving me a final answer of 280 squared inches. And last but not least, we have to solve for the left and the right. Area equals length times width. Area equals here, we see that one side length is 6. Even though this is not labeled, we know that because this side here, or this edge is parallel to the opposite side that's labeled as 14, we can take that number and plug it in. And if we multiply 6 times 14, we get an answer of 84 squared inches. This is for that left side that we see there, but knowing that we have to account for 2 different sides, we're going to go ahead and multiply that by 2, giving us an answer of 168 squared inches. Okay, now we can go ahead and add these 3 together. Again, you can either add these 3 numbers, or you can go ahead and separate these and say that the bottom was 60 inches, squared inches, the front was 140 squared inches, the back was 140 squared inches, left was 84, right was 84. When you add these 6 sides together, or when you add these 3 computations that we just did together, we get a final answer of 508. And this is 508 squared inches. And we would say this is surface area. So surface area equals 508 squared inches. Moving on to number 10, we are being asked what the volume of the jumbo box is. Now, this is a little bit different than surface area. In surface area, we've only worked with the length and width of the faces. Now we are using all 3 dimensions, the length the width, and the height, which is going to give us the total amount of space inside of a 3D object. So knowing this, I'm going to go ahead and plug in my formula for volume, which is volume equals length times width times height. I can go ahead and plug in my my dimensions, which are 6, 10, and 14. I know 6 times 10 is 60, and 60 times 14 is 840. So the total volume of this shape of the jumbo box is 840 inches cubed. It's very important to make sure that we are labeling our units cubed, because we are now dealing with the 3 dimensions, with length, width, and height. If we were only working with length and width, like we have been in surface area or the smaller areas of the shapes, then it would just be squared because it's 2 dimensions, length and width. Very similar problem in the next one. We are asked for the volume of the microbox. We know volume equals length times width times height. We can plug in our numbers and see that this is 3 times 5 times a height of 8. 3 times 5 is 15, and 15 times 8 is 120. So we have a total volume of 120 cubed inches, or inches cubed. Okay, so that completes all the work for number 11. Last but not least, we have problem number 12. It says, suppose the theater decides to have a third popcorn size, the super box. They want the super box to have a length of 6.5 inches, a width of 6.5 inches as well, and a height of 11 inches. Which of the 3 boxes holds the most popcorn, and explain your reasoning. So, knowing that we've already solved for the volume of the smaller box, which is the micro box, we've solved for the volume of the jumbo box, we already know how much those contain. Our question here is, will a box that has these dimensions, 6.5 by 6.5 by 11, give us a larger area than 840 or 120? We're going to go ahead and get started and see. Starting with this problem, as we did with the last 2, let's go ahead and include our formula, volume equals length times width times height. We can go ahead and plug in our numbers. I know this is 6.5 for our length, times 6.5 for our width, times 11 for our height. You may need a calculator for this part, but if you multiply 6.5 by 6.5, we do get 42.25, or 42 1/4, thinking back to fractions, which is a fourth. And if we multiply that by 11, we get a final area of volume equals 464 3/4. This is 0.75, which is the same thing as 3/4. So the question is this larger than the jumbo box? And the obvious answer is no, it is not. Because we know that the jumbo box gave us a total volume of 840, and 464 is significantly smaller than 840. So to answer this question, it says, which of these 3 boxes holds the most popcorn? I'm going to go ahead and say, of the 3 boxes, the jumbo box holds the most popcorn because it has the largest volume. And again, anything along these lines will be a good response. If you want to say that after finding the volume, 840 is larger than 464, you can explain it that way. But the goal here is to see and find that of the three, the jumbo box is definitely the largest. The super box that they just made is probably their medium size, and obviously the micro box is their small size. And that completes the review here for the CNS unit review. Go ahead and make sure you go back and replay any parts that you need to see to help you, and good luck.